Okay, good morning. Indicator or agent that indicates the state or level of something. Also, we can define in chemistry an indicator is a substance that changes color to signal a chemical change, such as the completion of a reaction in a titration or the acidity of a solution. Common indicators and their pH range: methyl orange 3.1 to 4.4, red to yellow, methyl red 4.2 to 6.3, red yellow, bromothymol blue 6 to 7.6, yellow blue, phenolphthalein 8.3 to 10, colorless pink. Methyl orange 3.1 to 4.4, red yellow, methyl red 4.2, 6.3, red yellow 4.2, 6.3, bromothymol blue 6, 7.6, yellow blue, phenolphthalein 8.3, 10, colorless pink. Properties of indicators. They are weak acid or weak base, color change over a narrow pH range, usually 1 to 2 units. The pH range where the color change is called indicator range or transitional interval. Color change occurs due to change in structure when indicator ionizes. Indicator must be chosen so that their pH range overlaps the equivalence point of titration. Types of indicator: redox indicator, acid-base indicator, adsorption indicator. Redox indicator, compound which shows different color in the oxidized and reduced form. Self-indicator, colored substance may act as its own indicator, for example, potassium permanganate. A specific indicator is a substance who reacts in a specific manner with one of the reagent in a titration to give color. For example, starch produces deep blue color with iodine and thiocyanate ion, which produces red colors with feldspar ions. External or spot test indicators: when a chemical species is externally added to act as an indicator is called external indicator. Potassium ferrocyanide acts as external indicator when ammonium sulfate reacts with potassium dichromate. Internal indicator, true redox indicator, an indicator which itself undergoes oxidation reduction, may be used and shows different color in the oxidized and reduced form. For example, potassium permanganate. Acid-base indicator. An acid-base indicator is a weak organic acid or weak base whose ionized and unionized forms have different colors. Its color changes over a specific pH range called transition interval. An adsorption indicator is an organic dye used in the precipitation titration. For example, argentometric titration, whose color change due to adsorption onto the sulfate of precipitates formed during the titration. These indicators work by getting the adsorbed on the precipitate surface only after the equivalence point, producing distinct color change. Theory of acid-base indicator. An acid-base indicator is a weak organic acid or weak organic base whose undissociated form and dissociated form have different colors. Because of this, the indicator changes color when the pH of the solution changes. Acid-base indicators are organic substances which consist of different color in acidic and basic. Various acid-base indicator shows that the color change in different pH range. Westerwald theory. Some assumptions of Westerwald theory of indicator are as follows. Acid-base indicators are regarded as organic weak acid or weak base. Acid-base indicators are undergo partial ionization in water to furnish S plus ion or hydride ion or hydroxide ions. Hence, degree of ionization can be changed by changing the concentration of these ions. Undissociated form of indicator has the different color than the dissociated form of indicator. The color of indicator depends upon the equilibrium of indicator in aqueous solution. Yes, first, if indicators are considered organic weak acid, then ionization takes place. Applying the law of chemical equilibrium, when K ln is the ionization constant of indicator, Kin, or indicator constant, chemical species in large brackets stands for molar concentration of corresponding chemical species. So we can write S plus Kin, Sin over In. Taking log to the both sides, minus log is plus, minus log Kin, Sin over In minus log is plus equal to minus log K In plus Sin over In minus. Again, we can write okay. Let's see again. Taking log on both sides, minus log is plus, minus log K In, Sin over In minus. Again, we can write, okay, log Sin over In, multiplying by minus, and we get log minus log is plus equal to minus log Kin plus log In over Sin. Again, minus log H plus equal to pH and minus log K in equal to pKin. So we can write pH equal to pKin plus log in over HIN. Let us take an example of phenolphthalein, which is regarded as weak organic acid. Phenolphthalein is colorless and its unionized state, while it has the pink color and its ionized state. Only when the excess of ammonium hydroxide is added, then only pink color appears. Okay, second, if indicator is considered as organic vehicle base, then its ionization can express. Applying the law of chemical equilibrium, taking log on both sides. So P OH equal to P IN plus log IN plus INOH. Let us take an example of methyl orange. Methyl orange is regarded as weak organic base. The ionization of methyl orange can be expressed as methyl hydroxide, dissociate, light yellow, amphibly ionized pink. In acidic medium, the excess of H plus ions combine with hydroxide ions to form water, and equilibrium shifts towards the right, producing more Me plus. So methyl orange, so pink color in acidic medium. In alkaline medium, the presence of hydroxide ions acts as common ion. The equilibrium shifts towards the left, and ionization of methyl orange is suppressed, so the color is slightly low. Methyl orange is not suitable indicator for the titration of weak acid. With base, weak acid furnishes low concentration of hydride ions, and it is sufficient to combine with hydroxide ions to shift the equilibrium forward effectively. Quinoid theory. Some important points of Quinoid theory of indicator are the acid-base indicators are aromatic compound and can exist in two tautomeric forms having the different colors. These two tautomeric forms have different structures. These are the benzenoid form and quinoid form. Benzenate and quinoid form. The quinoid form has more intense color than the benzenate form. Out of these two tautomeric forms, one form can exist in alkaline medium. When pH value of solution is changed, interconversion of benzenoid and quinoid form occurs. Then color of indicator changes. The color changing mechanism of methyl orange and phenolphthalein are given below. Color change in methyl orange. Methyl orange imparts pink or red color in acidic medium. The quinoid form exists in acidic medium and so intense color, while benzenate form exists in alkaline medium and so light yellow color. Acidic medium quinoid form pink color and alkaline medium benzoate form light yellow color. Color change in phenolphthalein. Phenolphthalein is colorless in acidic medium, while it imparts pink color in alkaline medium, and the benzoate form exists in acidic medium and is color while the quinate form. Acidic medium benzoate form colorless, alkaline medium quinate form pink. Okay, it's all about theory of acid-base indicator. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for facing. That is now. Bye bye. See you again.